Alright, so what we're going to start doing next is we're going to start looking at our trig circle as a function. So what we have in front of us right now is a demonstration that I'm going to be using from Wolfram. And if you download this application, you can start trying and play around with the different types of functions. So we can look at sine, cosine, tangent. You can also find other demonstrations for other topics. At the present moment, what I want to do is start rotating this dot around my circle. So in other words, I'm going to be graphing on my x-axis the angle theta. And as theta is going to increase, I want to see what happens to the value of my sine of theta, so the y value. So on the x-axis, I'm going to be graphing my theta, or the angle of rotation, and on the y-axis, I'm looking at the sine of that angle. So as I start, I know that at pi over 4, I'm going to be increasing in the value of my theta. So it's going to be root 2 over 2. And that's from our remarkable angles chart. Now I know that once I reach pi over 2, the value of my sine of theta will be 1. If I were to continue rotating around my circle, I would get the 3 pi over 4. And again, I would be at root 2 over 2. And then when I get to a pi rotation, or 180 degrees, I know that I'm back at the value of 0, because that coordinate is negative 1, 0 on my graph. If I were to continue, now I do have a magnitude of root 2 over 2. However, it is negative, because in the third quadrant, the sign is going to be negative. And if I were to continue at 3 pi over 2, I would reach a value of negative 1. And this would continue until I get back to 0 when I make a full rotation. So in other words, this graph is what we call the sine function. This is your basic sine function. And how did I make this basic sine function? Well, all I did is I rotated around my trig circle, and I can also go in the opposite direction. Right? So going in the opposite direction, I would end up going into the negative values. So a negative rotation would bring me in quadrant 4 first, and then I would get to quadrant 3. At pi, or in this case a rotation of negative pi, I reach 0 again, and then I would be increasing all the way until I get to my negative 2 pi, which is really a rotation of 360 degrees, but clockwise rather than counterclockwise. So these functions are our sine functions, and they are periodic functions. So let's look more in detail at our sine function. What is our sine function? Well, as we just saw, this is the graph that we illustrated. So as I was rotating around my trig circle, this is what I end up with. So some properties. Well, my period, it's basically the interval over which the function is going to repeat. So if I were to continue going around and around and around my trig circle, I would get this repetitive increase and decrease in my waves. In other words, the function is repeating itself. So how do we get the period? Well, we ask ourselves, when will our function start repeating? And as you saw, it would be at 1 turn around your circle, which is equivalent to 2 pi. So your period is 2 pi. So every 2 pi, you will end up with this repetitive pattern. Now, what's your amplitude? Well, your amplitude is going to be the distance between the top and halfway. So this is what I call that halfway line. And the halfway line is going to be halfway between the maximum and the minimum. So how do we find our amplitude? You take the maximum and you subtract your minimum from that, and you divide it by 2. For your basic sine function, so for this trig function that we just saw on our circle, you are going to get a value of 1, because your maximum is 1, your minimum is negative 1. 1 minus negative 1 is 2 divided by 2, and you get 1. Now your domain. If you were to continue rotating around this circle over and over and over, you would realize that you have a domain of all real numbers. But your range in this case is limited to negative 1 to 1. In this case, we have several zeros. So if I were to just look over 0 to 2 pi. So now I'm restricting my domain to just one period. So whatever is in red, I want to know what my zeros are. And they would be 0, pi, and 2 pi. Now again, this is only for my basic sine function. So just to recap, our amplitude is from the highest point or the lowest point to your halfway line, and your period is going to be before you start repeating the same recurring pattern. So let's look at the sine of our function. So between 0 and 2 pi, again, so I'm restricting my domain. So just for one period, when am I positive? So between 0 and pi. So when x is an element of 0 to pi, I would be greater or equal to 0. And if I would say the opposite, when am I negative? Well, it obviously has to be between x of pi to 2 pi. So the variation of my function over that same interval, so I want to know when I'm increasing. So just by looking at your graph, you can say, okay, well, if you are going up, you are increasing. So from 0 to pi over 2, you increase. Once you get to pi over 2, you now start decreasing. So this would be the interval of decrease from pi over 2 to 3 pi over 2, which is why we have decreasing here. And then we start increasing again from 3 pi over 2 to 2 pi. Now again, you're always reading the x values on your axis. So what about the extrema? Well, we know that our maximum is 1, and we know that our minimum is negative 1. Now here's a really important note. If I were to have a rotation of a negative angle and take the sine of that, that would be equivalent to me saying the negative sine of that angle. So in other words, whenever you have a negative rotation, just remove it from the inside and bring it on the outside. So if I were to recap just again, what I want us to do now is start looking at this function in terms of the different parameters, because we are going to start putting parameters in here. So your starting point, this point where your function is going to start, so in this case 0, 0 is called your HK. And we also said we have our amplitude and we have our period.